Hey guys, it's Mr. Regam. Today we're going to look at solving systems of equations by graphing. Essentially what we're going to do is we're going to graph two or more lines and we're going to find where they intersect, and that point of intersection will be the solution because we're looking for that point that would be on both lines. So if I'm just looking at this picture right here, we have the green line, we have the red line, they intersect at the point -3, -4. That would be our solution. Alright, let's try some. So let's do y equals 2x minus 1, and we'll do y equals 1/3 x plus 4. Alright, so we're going to graph the two lines. They're both in slope-intercept form, so it'll be real easy to graph. The first line, y equals 2x minus 1. I have a y-intercept there at -1. My slope is 2, which I can think of as 2/1 for my rise of 2, my run of 1. So I rise up 2, I run 1. Sorry about that. I'm going to rise up 2 again, run 1. And you'll see we want to get several points. Only doing 2 or even 3 points sometimes isn't enough because it's real hard to see at what point they intersect at. So I'm going to rise up 2, run 1 again, rise up 2, run 1. Alright, and I'm going to draw my line. Arrows, because this is a line. Alright, then we'll do y equals 1/3 x plus 4. My y-intercept is 4, 2, 4. My slope is 1/3, so rise of 1, run of 3. So I'm going to rise up 1, run 3, 1, 2, 3. See, it's right there. Rise up 1, run 3. Rise up 1, run 3. I'm going to draw my line. And then I can see my point of intersection is right there. It is the point 3, 5. And that's the solution. Now, if I wouldn't have put all those points on there, I might have been a little bit off on my lines, and I might not have seen exactly what that point was. That's why it's better to plot a few points instead of just 2 or 3. All right, let's try another one. Let's do x equals 5 and y equals x plus 1. Alright, so x equals 5, real easy. We know that's a vertical line going through 5 on the x-axis. So we have our vertical line. Y equals x plus 1, already in slope-intercept form, y-intercept of 1. Our slope, remember when there's not a number in front of x, we know there's a 1 there. So that's 1/1. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. Keep doing that. And then I'm going to draw my line. And I can see my intersection is right there. And that's at 1, 2, 3, 4, 5 for my x coordinate. And 1, 2, 3, 4, 5, 6 for my y coordinate. So the solution will be 5, 6. Now let's do another one. Let's try 4x minus 2y equals -2, and x plus y equals 4. Alright, now these are not in slope-intercept form. Actually both of them are set up in standard form, and if I wanted to graph using intercepts, that probably wouldn't be bad. But I'm going to put them into slope-intercept form and then graph it that way, because I can see if I try and do intercepts, looks like I'm going to come out with some numbers that aren't going to be integers, and if I start getting in with fractions and decimals, it's going to be hard to pinpoint where the points are and really get a good idea of where this intersection is. As I'm explaining that, you might be saying to yourself, well, this method of solving by graphing doesn't seem like the best method, and if that's what you're thinking, you're right on. It's a good method to kind of start out with, give you a good idea of what we're doing, what the solution looks like, but we will move on from this and we'll do a more algebraic way of solving these problems. So let's go to this 4x minus 2y equals negative 2. I want to get that into slope-intercept form, so I'm going to subtract 4x on both sides. Negative 2y equals negative 4x minus 2. Divide by negative 2. Everything gets divided. Negative 4x divided by negative 2 is positive 2x. And then this could be thought of as plus and negative. And then we get negative 2 divided by negative 2 is 1. So y equals 2x plus 1. For x plus y equals 4, that one's a little easier. Let me just subtract x on both sides. And I get y equals the opposite of x, or negative 1x plus 4. Alright, so these are our two equations in slope-intercept form. Alright, so y equals 2x plus 1. Y-intercept of 1. Slope of 2, so that's a rise of 2 or run 1. Remember, I'm going to do several points here. Draw my line. There we go. Y equals the opposite of x plus 4. My y-intercept is at 4. Opposite of x, which is the same as negative 1x, which would be negative 1 over positive 1. So I'm going to rise negative 1, which is to go down 1, run 1, down 1, run 1, down 1, run 1. And that's obviously enough for us to see where that intersection is. And it's right here. And that would be at 1, 3. So our solution is the ordered pair 1, 3, or the coordinate 1, 3. All right, let's do another. At this time, we have y equals 3x minus 1 and negative 6x plus 2y equals negative 4. All right, y equals 3x minus 1 is already set up for us. Slope-intercept form. Let's take this other equation and put it in slope-intercept form. So I'm going to add 6x to both sides. That cancels. 2y equals 6x minus 4. Divide everything by 2. Y equals 3x minus 2. Alright, so I'll be using this equation and this equation. So we'll start with y equals 3x minus 1. Our y-intercept is at negative 1. Our slope is 3, which 3 over 1. So rise 3, run 1. Rise 3, run 1. Rise 3, run 1. Draw my line. Alright, now y equals 3x minus 2. My y-intercept is at negative 2. And my slope is 3, which is 3 over 1. So rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And at this point, you're probably noticing that those two lines are parallel, even with my squiggly drawing. And you probably saw it already because the slope of both lines was 3. Since these lines do not intersect, then we have no solution. And that will happen. When you have parallel lines, they will not intersect, therefore you will have no solution. Alright, let's take a look at one more. We have y equals 1/2 x plus 2. And we have negative 2x plus 4y. Oops, that's a y. Equals 8. Alright, y equals 1/2 x plus 2, already in slope-intercept form. Y equals 1/2 x plus 2. I'm sorry, that's already set up. Negative 2x plus 4y equals 8. You know what, that one, why don't we do intercepts with that one? So why don't we leave that one the way it is? So let's graph y equals 1/2 x plus 2 first. All right, 2 is our y-intercept. Our slope is 1/2. So we're going to rise 1, run 2. Rise 1, run 2. rise 1, run 2. And don't forget, it could also be negative 1 over negative 2. That also equals positive 1/2. So I could have gone down 1, left 2, down 1, left 2, down 1, left 2. I mean, that's another way to use our slope. Graph our line. Alright, now for our second equation, if we want the y-intercept, then we'll put 0 in for x. So negative 2 times 0 will be 0, and we'll just be left with 4y equals 8. Divide by 4, y equals 2. So our y-intercept is 0, 2. For our x-intercept, we'll put 0 in for y. So 4 times 0 is 0. We will be left with negative 2x equals 8. Divide by negative 2, and x equals negative 4. So our x-intercept is going to be at negative 4, 0. So there's our 2 points. We're going to draw our line. And what happened is they are both the same line. I drew one line on top of the other. Now, the reason that happened is if I take this and I put it into slope-intercept form, it ends up being y equals 1/2 x plus 2. That ends up being the same as that. You just couldn't tell because I left it in standard form and graphed it with the intercepts. When I'm graphing two lines that are the same line, then there's an infinite number of solutions. Every point on there. So, infinite number of solutions. So sometimes our intersection is 1 point. Sometimes there is no intersection, there's no solution. And sometimes when it's the same line, we have an infinite number of solutions. Alright, there you go, guys. That is solving systems of equations by graphing. This is our introduction into this topic, and then we'll move from here into solving in a more algebraic way. Good luck.